sixth spot is the MiG-31 Foxhound, reaching an impressive Mach 2.83. This is the fastest combat aircraft still in service today. To handle the immense heat and stress of these speeds, the airframe was built like a tank, composed of 80% nickel steel and 16% titanium. The Foxhound was built for one purpose: to defend the vast, empty skies of Siberia. But its speed wasn't just for high-altitude interception. In a rare and remarkable feat, the MiG-31 is also capable of sustained supersonic flight at low altitudes, reaching Mach 1.23 near the ground. At its heart is a powerful phased array radar, one of the first ever fielded on a fighter jet, allowing it to track multiple targets from hundreds of kilometers away. Today, it serves as one of the few aircraft capable of carrying and launching the Kinzhal hypersonic missile, a role that solidifies its strategic importance. Because F-5 is the truly awe-inspiring North American XB-70 Valkyrie. At a blistering Mach 3.08, it remains the fastest bomber ever built. Looking like a giant paper airplane from another world, the Valkyrie was a strategic bomber designed to fly at 70,000 feet, faster than any interceptor could reach it. Powered by 6 massive General Electric YJ-93 jet engines, it was an engineering marvel. To survive the intense heat of high-speed flight, its skin was made not from aluminum, but from advanced stainless steel honeycomb panels and titanium. Its most iconic feature was its folding wingtips, which could droop down as much as 65 degrees. This improved stability and allowed the aircraft to literally ride its own shockwave, a phenomenon known as compression lift. But its incredible performance couldn't save it. The rise of effective surface-to-air missiles made high-altitude bombing too dangerous, and the loss of the second prototype in a tragic mid-air collision sealed the program's fate. Only one Valkyrie survives today, a breathtaking monument to peak Cold War ambition. Number 4. The Bell X-2 Starbuster. Before humanity could fly faster, it first had to conquer the intense heat of the thermal barrier. This was the sole mission of the X-2. It was a pioneer in high-temperature materials, built with a skin of K-Mon-L copper-nickel alloy and stainless steel specifically to withstand conditions that would destroy other aircraft. Dropped from the bomb bay of a B-50 bomber, this rocket-powered research plane was designed to push the known limits. On September 27, 1956, pilot Milburn Apt achieved that goal, becoming the first human to fly past Mach 3, reaching a top speed of nearly Mach 3.2. But this knowledge came at a tragic cost. Immediately after setting the record, Apt's aircraft fell into the same kind of inertial coupling that Chuck Yeager survived, and he was unable to escape. His sacrifice, however, provided priceless data on high-speed aerodynamics and structural heating, paving the way for every high-Mach aircraft that followed. The bronze medal goes to the MiG-25 Foxbat. This is the aircraft that terrified the West. For years, the Foxbat was a phantom to Western intelligence. Radar tracks showed an aircraft with seemingly impossible speed and altitude, creating a legend long before its full capabilities were understood. The terrifying reality of this legend was confirmed in 1971, when Israeli radar stations tracked a Foxbat flying over the Sinai Peninsula at an untouchable Mach 3.2. The secret to its speed was the two colossal Tumansky R-15B-300 engines, a direct evolution of the powerplant first tested in the Ye-152. As pure turbojets, they excelled in the thin air of high altitude, allowing the Foxbat to become the fastest combat jet in history. However, pushing to Mach 3.2 was a dangerous gamble that risked destroying the engines. When a Soviet pilot defected with his MiG-25 to Japan, Western engineers were shocked to find it was built not of advanced titanium, but of heavy nickel-steel alloy. It was a brute force solution to speed, a monster that also holds the official altitude record for a jet aircraft, soaring to over 123,000. Just missing the top spot is the iconic Lockheed SR-71 Blackbird, the legend itself. At Mach 3.3, this is the fastest air-breathing piloted jet aircraft in history. For over 30 years, it flew with impunity over hostile territory. If a missile was launched at it, the standard procedure was simple: accelerate. But the Blackbird was a machine of extremes. While other aircraft used acrylic canopies, the SR-71's was made of solid quartz to survive the blistering heat. Its titanium body was built with intentional gaps to allow for thermal expansion, which meant on the ground it constantly leaked fuel. But the real danger wasn't the leak. It was the intense heat of high-speed flight, risking the explosion of fuel vapors. To prevent this, a nitrogen system inerted the tanks as they emptied, keeping the aircraft safe from the inside out. And long before GPS, the SR-71 navigated by tracking the stars. An automated astro-inertial system allowed it to pinpoint its location with incredible accuracy. Power came from its J-58 engines, hybrids that could shift from normal jet operation to a near-rocket-like mode at high speed. This masterpiece was the final evolution of a design that began with the CIA's secret A-12 spy plane. The SR-71 perfected the concept, becoming a strategic reconnaissance platform whose pilots wore full-pressure suits like astronauts flying on the very edge of space. At number 1 is the undisputed king of speed, and it's not even close, the North American X-15. This machine is in a league of its own. On October 3, 1967, test pilot William J. Knight pushed this incredible aircraft to its absolute limit, reaching Mach 6.7, nearly 7 times the speed of sound. Released from a B-52 bomber, the X-15 fired up its colossal XLR-99 rocket engine. This power plant generated over 57,000 pounds of thrust and burned through nearly 7 tons of liquid propellant in just about 80 seconds. This raw power pushed the X-15 not only to record speeds, but also to record altitudes, with some flights soaring over 67 miles high, well into space. It flew so high and so fast that 8 of its pilots were awarded astronaut wings. To survive the searing heat of re-entry, its body was covered in a nickel-chromium alloy called Inconel X. To steer in the airless void, it used small hydrogen peroxide thrusters, just like a real spacecraft. Over the course of 199 flights, the X-15 program gathered priceless data that directly contributed to the Mercury, Gemini, and Apollo space programs. It remains the undisputed king of speed, holding the official record for the fastest ever manned flight within the atmosphere, a record that has stood untouched for over half a century. 10 aircraft, 10 legends, each a chapter in our relentless pursuit of